Electric Power Research Institute, located in Charlotte, North Carolina, has several labs that support materials and repair research. The welding lab, machine shop, metallurgical lab, characterization lab, and high-temperature mechanical test lab are all utilized by the materials and repair team. Components are received through the high bay areas where large cranes can move up to 15 tons. Components and sections are heat-treated or aged in furnaces. The high bay houses critical components for research studies. At EPRI, we use high-precision 3D scanning to model large components. These models can be used to determine locations for sectioning and sample removal. The 3D models can also determine critical dimensions in hard-to-reach areas. Large components removed from power plants are sectioned in high bay areas with large vertical and horizontal band saws. These saws are some of the largest on the east coast of the United States. Sectioned components are then sent to the machine shop for processing. The machine shop has manual lathes, mills, and saws. There are also several different automated machines and processes used, such as electric discharge machining as well as CNC lathes and mills. The CNC lathe is typically used to machine creep rupture samples with dimensions to tight tolerances. The diverse set of equipment also allows for machining of non-traditional samples. CNC programming is used to automate machining of threads and other hard-to-machine features in samples for high-temperature mechanical testing. EPRI's high-temperature test lab is equipped with specialized creep frames to carry out not only traditional creep testing, but also specialized tests in non-traditional geometries. Load capacities range from 600 pounds for small samples all the way up to 50,000 pounds for large feature-type tests. Feature testing of full-size welds allows EPRI to evaluate creep behavior of components under service-like conditions in a well-controlled lab. These results inform repair weld guidelines, NDE sample development, and condition assessments of removed components. 3D CAD software is used to design sample geometries that maximize the area of cross welds being tested. Extensometers are also used to capture strain measurements for the entire duration of the test. EPRI focuses on long-term creep testing in feature samples to provide members with relevant results. Tests often exceed 10,000 hours. EPRI has more than 50 creep rupture frames to accommodate a wide variety of testing. Sample information is entered into the software that keeps track of all running creep frames. The creep frames automatically record continuous strain readings and temperature during the test. The furnaces keep temperature stable to within 1/10 degree Fahrenheit in standard samples. Failed samples are carefully sectioned using CNC-programmed electric discharge machining. After sectioning, samples are brought to EPRI's state-of-the-art metallurgical lab for metallographic preparation. They are then polished down to a sub-micron finish using automated procedures to ensure consistent, high-quality surface finishes. Polished samples are evaluated with both optical and digital microscopes to evaluate the extent and location of creep damage. Over the last decade, EPRI has invested over $6 million in its high-temperature mechanical testing capabilities and advanced microscopy. The materials and repair team is leveraging these capabilities to solve complex problems for its members and to execute an emerging and diverse research portfolio unlike anywhere else in the world.